Welcome to Class 13.1, Replacing ECM or X13 motor with a PSC motor. In this bonus lesson, you're going to learn a real-world solution for one of the most common problems in the field: what to do when an ECM or X13 motor fails and you need to replace it with a more affordable option. This is a valuable skill, especially when the customer doesn't want to spend $700 or more on a factory replacement motor. Let's break it down step by step. Why convert to a PSC motor? Both ECM and X13 motors are electronically commutated. They have built-in modules that control speed electronically. They're energy efficient, yes, but also expensive and sometimes hard to find. In some air handlers, you can replace just the module, but in others, you must replace the whole motor and module together. If the cost is too high, a PSC motor can be a great alternative, but it's not plug and play. You need to modify the wiring to work with a PSC motor setup. And that's what we'll teach you now, what you'll need. To convert from an ECM or X13 motor to a PSC motor, you will need a compatible PSC blower motor, 240 volts, multi-speed, one capacitor, match the motor's specs, two relays, one for cooling speed, one for heating speed, wire strippers and connectors, a wiring diagram or basic knowledge of your air handler layout. Step 1. Identify the power source. TIS blower circuit runs on 240 volts. From the air handler breaker, you'll find two high-voltage wires, typically one red and one black. These are your line 1 and line 2, and they will feed the relays that power the PSC motor. Step 2. Install the two relays. You're going to use two SPST relays. One will activate cooling speed, the other will activate heating speed. Each relay will receive 24-volt signal from the thermostat, Y for cooling, W for heating, 240-volt high voltage from the air handler breaker, output to one of the motor's speed wires. Each relay works like a switch. When it receives 24 volts, it closes the internal contacts and sends 240 volts to the motor speed tap. Step 3. Understand the PSC motor wiring. PSC motors have several colored wires: black, usually high-speed blue or yellow, medium speed, red, low speed, white, neutral or line 2, sometimes line 1, depends on config. Brown and brown-white go to the capacitor. In this case, connect white to one side of the 240 volts, let's say line 2. Use the black wire for cooling. Connect this to the output of relay 1. Use the red wire for heating. Connect this to the output of relay 2. Now you have two speeds, one for cooling, one for heating, controlled by the two relays. Step 4. Wire the relays. Let's do the cooling relay first. Terminal Y from the thermostat sends 24 volts. This goes to one side of the coil on relay 1. The other side of the coil goes to COM and C. The switch terminals, usually labeled COM and NO, will carry the 240 volts from the air handler breaker and send it to the black wire of the PSC motor. Now the heating relay, terminal W, sends 24 volts. It energizes relay 2. The NO terminal of relay 2 sends 240 volts to the red wire of the motor. Make sure both relays receive line 1 from the breaker and line 2 goes directly to the white wire on the motor. Step 5. Install the capacitor. PSC motors require a run capacitor. Brown and brown-white wires connect to the capacitor terminals. Check the motor plate. It may say 10 microfarads, or 7.5, or 15. Always use the correct size and voltage rating, 370 volts or 440 volts. Mount the capacitor securely and avoid any short circuits. Step 6. Test the system. Now it's time to test. Set the thermostat to cooling. The Y terminal should energize relay 1, sending 240 volts to the black wire. Set the thermostat to heating. The W terminal should energize relay 2, sending 240 volts to the red wire. The blower motor should respond at the correct speed in each case. Always measure voltage between line 1 and line 2, not to ground. If nothing happens, check your relay coil voltages, capacitor connections, and wiring taps. Can I do the same for X13 motors? Yes, X13 motors, like ECM, also use electronic control modules, but they're slightly different. They use 24-volt signals for speed taps. However, the failure points are similar, and if an X13 motor or module fails, you can do the same PSC conversion with two relays, a capacitor, correct motor wiring,